Hello, welcome back, researchers. Okay, so this lesson starts a series of three on quantitative research designs. And first, we're going to talk about experimental designs. And this is adapted from chapter 10 in your textbook. So, what's an experiment? An experiment, you test an idea or a practice or procedure to determine whether it influences an outcome or dependent variable. Experimental design process is that you decide on which idea you want to experiment um, on. You assign individuals to experience um, whatever the thing is you want to test and have others experience something different. You determine whether those who experienced the idea or practice or procedure performed better on some outcome than those who did not. Okay, decide what you're going to do, you know, subject people to it, and then see if there was a difference in outcome. When do you use an experiment? You use it to establish probable cause and effect between an independent and dependent variable, and you want to control for all variables that might influence the outcome. And we use it when we're comparing two or more groups. And generally, as part of the design of an experiment, you will be comparing two or more groups or comparing an individual at two or more times. There are four criteria for saying that something causes something else, for making a causal inference. First of all, the two things should relate. A math curriculum should relate to math achievement, for example. There should be, there should be some kind of relationship between the cause and the effect. Okay, manipulation. Um, um, this idea that each participant can potentially be a part of the intervention or the control. The control group is the group that doesn't experience whatever this new thing is that you're testing out. That you're doing something. There's something that the researcher is actually doing. Is part of making causal inferences. Order, the cause has to come before the effect, and that's pretty straightforward. And finally, the elimination of alternative explanations. What else may account for a particular relationship? And so, depending on how an experiment is set up, experiments can be very useful for making a causal inference, for establishing cause and effect. Brief history of experiments in social science research. We started out with psychological experiments. Okay, so before social science experiments, there were plenty of experiments in chemistry and biology and other fields. But in the social sciences, in the late 19th and early 20th century, we started out with psychological experiments. Procedures for comparing groups started to be developed in the 1920s, as were statistics for comparing groups. The identification of types of experimental designs. Campbell and Stanley are credited with writing a very influential text on that in the 1960s. The idea that there are basic designs and threats to the validity of those designs were described by Cook and Campbell in the 1970s. Since 1980, there have been the use of very complicated experiments with many variables in education, and also observational studies tend to be more useful and more prevalent in education than experiments are because of issues of ethics. Okay, the steps in conducting experimental research are basically three main steps, but we can break it out into 8 steps. Decide if an experimental design fits your research problem. Form hypotheses that basically spell out what you think are going to be the cause and effect. Select an experimental unit and identify study participants. Select an experimental treatment and introduce it. Choose a type of experimental design. There are different ways you can set up groups usually in an experiment. Conduct the experiment, organize and analyze the data, and finally write a research report. There are certain key characteristics of experiments. First, random assignment is to use to control for extraneous variables, and we will not be going through 17 slides on this, so let me delete that. There's the idea of control over extraneous variables, which is one thing that made experiments in laboratories very popular. Manipulation of the treatment conditions, measuring the outcomes, comparing groups, and there are threats to validity to think about with experiments. First of all, random assignment. Okay, so in medical research, this is very prevalent. We're going to randomly assign individuals to conditions or groups, right? So we're going to say, okay, you are getting the new thing, you are not. Randomly, okay? And the reason is because we want the groups to be equal on all the things we can't measure, right? And we don't know, right? So if we randomly assign, we're hoping that a mixture of people end up in each group, and the groups are kind of similar. So random assignment equates groups and distributes variability between or among groups or conditions. And it's different from random selection probability sampling for reasons we won't get into. All right, control over extraneous variables. Extraneous variables are things that influence the outcome, but we want to control. We want to have control over things. We need to limit things. For example, we need to be conscious of participant selection, of the procedures, of the statistics that we use, and how the design is likely to affect the outcomes. Because we don't want there to be alternative explanations of our results than the thing that we're actually testing. For example, random assignment of participants before beginning the experiment, because it's not random if you do it later, if you do it based on some criteria other than just who walked in the door in a particular order. Other control procedures are things like pre-tests and post-tests, looking at covariates, matching participants, choosing homogeneous samples, or blocking variables. And we're going to talk about each of those. A pretest equates the characteristics of the group. And as educators, we know this. Unless you have a pretest, when you give the kids the test at the end of the unit, you don't know how much they grew over the course of the unit, how much they learned over the course of the unit, because you don't know, unless you had a pretest, you don't know what information they came in already knowing. Okay, if they already knew everything there was to know about Western expansion, for example, and you gave a test on Western expansion, you don't know the extent to which your teaching made a difference in their knowledge unless you have pretest data. So the pretest is the measure on some attribute or characteristic before participants receive the treatment, and the post-test is the measure after they've received the treatment. And we're using the term treatment in education. It's more like an intervention because this isn't medical research. Disadvantages: pretests take time. They can raise expectations, like, hey, here's the pretest, here's what you're gonna learn, and they can affect post-test scores as a result. So you give the pretest, you do something, and then there's the post-test. Covariates, variables that the researcher controls for using statistics. It relates to the dependent variable but not the independent variable. Okay, so um, whether, let's say I've got my high school biology kids in my first period class, and I've got my second period class, right? And so let's say I have a whole lot of kids who test as gifted in my second period class. Okay, I might want to say that, okay, I'm going to control for giftedness in my study, or identify giftedness in my study, because if they test as gifted, that might affect their scores at the end of whatever biology unit I'm teaching. And so we yeah, so covariates, other things we know about our participants, that aren't what treatment they're going to get, um, are things that are covariates. And ideas, we want to remove the variance, and we're going to be learning exactly what variance means soon. Not this week, but soon. Another way is to match participants. This is how we can deal with it. Another way to deal with extraneous variables. So we might identify one or more personal characteristics that influence the outcome. For example, if we believe that gender relates to, I don't know, acquiring computer programming knowledge. Okay, we might assign individuals with that characteristic equally to the experiment and the control group. So we'd have the same number of boys and girls in our class that's going to get the new programming curriculum, to the groups of boys and to the number of boys and girls in the class that's going to get the same programming curriculum that we've used for the past 5 years. Okay, so gender is one way we match. Pretest scores is another way, matching kids who come in with the same level of knowledge of the subject. And also individual abilities would be a third. A homogeneous sample is when we select people who vary little in their personal characteristics. So you might say, hey, my study, I'm really focused on knowing a particular thing, and I just want to kind of eliminate extraneous variables because it just adds too much, and I won't be able to see whether or not my program is helpful, unless I can kind of eliminate some of the noise of variability. So we might choose, let's say we're going to have one classroom get one reading curriculum, and another classroom get a different reading curriculum, right, at the elementary level. We might choose two classrooms that seem to be kind of similar. Each classroom, they have about the same number of gifted kids. They have about the same number of kids with identified disabilities. They have about the same number of English language learners. The teachers have about the same number of years of experience. We're going to have two very similar classes and have one be the control and one receive the treatment. Okay, and as a way to try and get control over some of these extraneous variables. But in schools, when do you ever have two classes that are so similar, right? So it's kind of hard to achieve homogeneous samples in education. Blocking. This is when you divide the participants into subgroups or categories, and you then decide, okay, this group is going to get this group is going to get that, this group is going to get da, 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 da. Often grade level is a blocking characteristic. Age, and here you might want to assign equal numbers to different groups. That kind of thing. Blocking is a term for how you can accomplish that, and that's used a lot in psychology experiments. Not so much in education, for reasons that I'll get into in a little while. Now, there are the treatment variables, right? This is what the researcher manipulates to determine the effect, right? And it could be categorical levels. Is is the instruction in small groups or large groups? Is the reading group, are the students getting phonics or whole language? Is the intervention in smoking cessation standard or standard plus health hazards? I think is was a example in your textbook. So the intervention, this is where you're physically intervening with or manipulating one or more condition. The researcher is doing something different to one group of people or versus another group of people. And individuals experience that something different in the experimental condition versus the control condition. You need to be able to manipulate at least one thing for it to be called an experiment. So, for example, let's say we're doing some kind of smoking cessation program. Independent variables might or control variables in this case might be things like age and gender. We can't change how old a person is just by saying we want to. We can't manipulate gender either. We can't manipulate what type of program or what type of instruction they're going to get in the program. And then later on we can test, our outcome might be how frequently they're smoking after they've gotten our treatment. Okay? Or one of a variety of conditions. How frequently are they smoking after they've gotten the normal lecture we always give? How frequently are they still smoking after they get a lecture, our normal lecture, plus a discussion of the health hazards? And how frequently are they still smoking when they get the health hazards, as well as slides of damaged lungs, for example. And that's what we manipulated. Those are our 3 treatment conditions. Okay, outcome measures. The outcome is the dependent variable, the response, the criterion, the post-test. What do I have criterion there? Okay. This response or the post-test. Let's stick to those. They're the presumed effect of the treatment variable. Okay. Let me delete that. And they need to be a responsive and valid measure. Something that is likely to change as a result of your intervention. It could be achievement test scores or aptitude. It could be some kind of mental health assessment, that kind of thing. We do group comparisons. That we're used to in education, right? We're going to compare how those who received the new curriculum did compared to those who received what we've always done. And we compare both the average or mean and the variability or variance within and between the groups. And we're going to be learning more about means and variance soon. Okay, so for example, if you figure 10.4 in your textbook talks about shows how a couple different ways you can design an experiment. Okay, and you might different way. Let's say the experiment is about teaching spelling, right? Yeah. So you might have your regular spelling thing for one class, whatever you regularly do for one class. You might compare that class's performance to another class where they have a shorter spelling list. And finally, you might compare those two to some new thing you're doing around error correction. And you're looking at spelling accuracy maybe across 3 weeks. And so comparing the test on Friday of the first week to the test you know, maybe you're going to average them and then compare the groups, something like that. And maybe you come out and you find out that um, the 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 class that got, you know, the class that got the usual, maybe they on the third time they're going through this, maybe they on average they get 11 words correct. The class that got the reduced word list, maybe on average they're by the third test they're getting 10 words correct. The class that um, got your new error correction procedure, maybe on average on the third test they got 13 words correct. Okay, and then you're going to be using some kind of statistical test to see what kind of conclusions you may be able to draw from that. And we're going to be learning all about that. Okay, so there are different types of experimental designs. But let's pause here, take a little break, have a little stretch, and come back and then talk about between group and within group designs. Okay? See you soon. Bye bye.